All right, so the question we have with us is implement queue using stacks. So, for this question, the basic thought process has to be that you will be having uh, two stacks, uh, and you have to implement a queue using those two stacks. All right. So the basic thought process has to be that, all right, uh, implementation of a queue, that means that queue works upon the principle of first in first out, or last in last out, and stacks is kind of opposite. It works on the principle of last in first out, first in last out. So the thing is that in order to do that, we will be requiring two stacks. So first of all, if in a stack we are having the components, you know, we have implemented the components, what we will be doing is that now when we have to remove, so if in stack you put in the components, suppose you put 1, 2, 3, 4. Now if you have to remove, the stack will be removing the top one, last in first out, but the queue would be requiring to remove the bottom one, first in first out. And it's not possible to do, you know, from the bottom in stacks. You can't remove elements from the bottom in a stack. So yeah, the thing is, the second stack that you're going to use is, in that second stack you're going to push the elements that you're going to pop from the first stack. When you pop these elements from the first stack, you push them in the second stack. So the top most element in the first stack is now the bottommost in the new stack, stack 2. And the bottommost element that you had to remove is now at the top. You pop it. uh, that means, like, don't pop it, don't remove it, just do one thing, just return that. That's what is required when you like remove an element, you return it actually. So you know, just peek, you know, stack dot peek, you know, stack 2 dot peek. This will be, you know, giving you the topmost element, and then you add them again while you remove this. So in this way you have removed the element from the stack using a queue sort of implementation. But the time complexity for this removal is O of n, because you had to, you know, go through all the elements. So yeah, that's the time complexity. For insertion it's O of 1, you just keep inputting. But for removal it's O of n, because you had to, you know, first of all put all the elements there and then do it. So yeah. So having my queue in this class, what I can have is, I can have stack uh, integer type, yeah, integer type, and then I can say it's first. I can have the same thing as second. Yeah, now I have two stacks now in my queue. It's like basically a constructor. So for this constructor I can say that uh, first, that has been declared already above, equals to new stack, yeah, and then I can say that for the second as well, yeah, cool. Now for push I can say first dot push x, yeah, and then for pop I can say that while uh, first is not empty, so yeah, it's not empty, uh, do what, while first is not empty, uh, second dot push uh, first dot pop, yeah. So in second, keep pushing the elements that you're popping from the first. So till the time first is not empty, keep repeating that. And the moment first gets empty, then you have to be like int uh, int what? Int peak is second dot peak. So you just get the topmost element, and then you have to put them back again. So you're gonna be like, while let's copy that. Yeah. But here it's gonna be second, and we're pushing in first, and we are saying second dot pop. The moment it's done, you have to return peak. Yeah. Yeah. Wait. Return. In while I use peak, I'll have to return the topmost element of the stack. I have to return the topmost element of the stack. So when the thing is called, I say how to handle this peak thing. Stacks are not having any indexes or something. Wait a second. What's that for the answer? Alright, they want me to, have these two things. They want me to throw an exception, exception they want me to create an exception. And then, yeah. Or I said user size or something. So the moment it's 0, yeah, length minus 1, yeah, the topmost. Alright. Yeah, so it's basically exception type stuff. So I'll have to be like int length equals I don't think, wait, what is size? Let's see. Yeah, I have have the size, and if is 0, throw, wait, am I doing that right? Yeah. Throw, can I just name it massive, like um, exception stack is empty. I don't know what I'm doing, but let's see. Else return length minus 1. But how do I return that element? Element at empty stack exception. Alright, throw new empty stack exception. Through empty stack exception. Element at yeah. When return size equals 0 or something. Return size, yeah. Let's see. Yeah, of course you can't find that something. I don't know what to do about this. Wait. I'll have to okay, so they want me to, like, say push is gonna push, and then pop is gonna alright. Wait a second. How can I modify this solution? I understand, like, they want me to here, in this case they want me to be like, alright, what is pop gonna do is pop is gonna peek. It's gonna call peek. So it's gonna take the topmost element, and then I'm gonna return output. Yeah, I'm gonna return output.pop. So yeah, I return the topmost element because of this peek thing. And what peek is gonna do is it's gonna see if output is empty. Yeah, the second one is if it's empty. And while the input is not empty, output.push. What? Alright, it's gonna see, alright, if the second stack is empty, it's like, yeah, it's empty. So what it's gonna do is gonna say, like, alright, while the input is not empty, keep, putting the elements in the second, and then it's gonna return output.peak. Alright. All right, I understand. And then public boolean empty. It's gonna say return input is empty and output is empty. Okay. Oh, okay. Office one. Okay. All right, let's try to do it. Yeah. Push is fine. Let's remove this because push is fine. What I'm gonna do is for pop, I'm gonna say for pop that all right. Pop has to pop will call peak. What will be happening is that the moment pop calls peak, it's gonna take the topmost element first of all. That's something that has to be done, and then what's gonna happen is after it has taken the peak, pop is gonna return, but pop has to work with inclination with this because here we're gonna remove everything. And yeah, wait. Yeah. So peak. Return. Uh, second dot pop. So what's this gonna do is it's gonna say that alright, when I call pop, you call peak. Peak is gonna give me the topmost element, and then return second dot pop. That is basically the topmost element that one has to return. Yeah. My question is that why we are putting second right here? Like, who knows? I mean, it's fine, but I don't understand. What is this second gonna do? Wait. says that returns output dot pop. My output is empty. Alright, I guess it's clear now. Thing is, like, if output dot pop is being done, output is like, like the stack thing. So yeah, it's gonna have the stack pop, and if there is nothing before it, it's gonna be the one I am creating. Alright, so it's, I guess, gonna be simple in pop. So I return, when I do in pop, I have this peak function right here, and then, but wait, why do I need to have the peak function right here? the peak element for the transfer of elements, which I did right here. I have to remove it. Alright, okay. So I guess it's going to be pretty to the point. I guess the peak function is going to be like, so basically what's happening is that here for int pop, I'm saying first of all transfer and then start to pop. Like the second dot pop. So the second dot pop is going to be the element that had to be removed. That's going to be on the top thing. First in, first out, that one. Alright, understood. Here what I have to do is I have to say that if second is empty, second is empty, while completely understood the logic, while first dot is empty, first dot is empty, while it's empty, do one thing, second dot push, first dot pop, keep pushing that thing in it, and then while it's done, return second dot I'm confused that my pop is returning second dot pop. So my peak is gonna return second dot pop, but isn't it gonna be like two pops? Wait, it's gonna be like second dot peak, so it's gonna then check second is empty, and while first is not empty, second dot push, first dot pop. It's gonna return second dot peak, output dot peak. Alright, now this output dot peak is basically, alright, understood. Basically this output dot peak is the function for the stack dot peak basically. So yeah, I'm going to return second dot peak, the topmost element. And then do I even need then return second dot pop? If I am returning second dot peak, why in pop method I need to have return second dot see, peak is gonna give me the topmost element. Pop is gonna remove and give me the topmost element. Alright. Yeah, understood. It's needed for the removal actually. Yeah, makes sense. Cool. For this, empty. If it's a boolean serve, is empty. First dot is empty. Should I be using all second? Right. Yeah, fine, makes sense. I can do it. It's for the stack, so both have to be empty. but there has to be something. Yeah, requirement. First dot is empty and second dot is empty. Accepted. Yeah, so yeah, I did have to look at the solution, but I guess I understood the implementation. So yeah, it would be working, I guess. Makes sense.